Welcome to the Glassworking Shop. In this video, I'm going to be assembling a chipstack using my chipstack assembly fixture and a hand torch. The chips were cut from the triangle that I made in the last video. This is the Damascus style murrine experiment where I layered together a bunch of different flat colored glass with a black border all squeezed together, and then squeezed some design into it and added some more stuff and built up a pattern. After I pulled, I got about, I don't know, 7.5 inches of usable material that was cut up into smaller pieces, and then off camera, I sized the triangles using the squeezer to get them a little more precise and get the corners a little sharper. And then after they were sized, I went back out to the wet saw and cut them up into slices, and then put the slices into the assembly fixture and adjusted a little bit using the lap wheel. Also off camera, I flattened some black color rods to use for a border and kind of like adjusted the edges and got the angles all to work. And now I have the pieces assembled and ready to go on the chipstack assembly fixture, and I'm going to be putting it together using a hand torch. Also, I'm going to be using a slightly different camera arrangement. I've got a GoPro now mounted overhead, and little bit by little bit as I experiment with different camera positions and camera settings, I think the videos are getting a little better. So here goes. The pieces, the assembly fixture and the triangle pieces have been coming up the temperature in the kiln, and they should be ready to go now. So let me make my way through this somewhat tight little maze here in my shop. It's like I really like having everything close together, but it does make navigating around just the tiniest bit of a challenge. So there's this guy in place, and check the camera to make sure that it's in frame. Doing a project like this with just one guy can be quite challenging. Getting all the cameras lined up and making sure everything's right. Okay, here we go. So I'm using the Mirage hand torch and a couple of little graphite tools, and first thing that I do is just kind of like heat the piece up very gently. The whole key to this process is to very, very gently heat the piece, and then as I heat the piece, the edges where the chips meet start rounding over. And that's actually why I have the border on the thing, because if I just kept my design all the way to the outer edge, I'd end up with rounded off edges on the outside. So after kind of overall general heating, just to get the thing somewhat up to temperature, I'm going to concentrate on the edges, and where they're kind of rounding off a little bit, I think that's a fairly good flame. I'm going to use this tool, which is a a graphite tool that I made. I got a kind of a little rounded 1/4 inch wide surface on it, and I'm just going to very, very gently just kind of touch with just the gentlest pressure, just touch those rounded edges where the chips meet, and kind of stick them together a little bit. The trick here, there's actually 2 tricks. First of all, the closer the chips fit, the better I am. The better the work comes out. And so I've been working on several things, obviously pulling more accurately, then in a secondary operation going back into the squeezer and resizing the pieces, and then finally, as I'm putting them in the assembly fixture, I do just the littlest bit with the lap wheel. I don't want to do too much, because if I grind away the pattern, then it's going to affect the way it looks. And so there's always a trade-off of, can I grind away a little bit of the mismatch and provide a really nice mating surface without distorting the pattern? Or do I want to get it hot and then try to very gently press it together without distorting the pattern? And I've had very good luck using the method of pressing together, and as my technique improves and as I practice, you see, I don't know if you can see on the video, how I'm closing up that hole in the end. Just a little bit, small amount of heat, small amount of pressure, and kind of gently force the hole to close up. This assembly process is actually done in multiple steps, and the first step is done in the assembly fixture with the fixture holding all the pieces together, but that only lasts just barely long enough to get the thing to stick. And once it's stuck together, it's not quite fused yet, but once it's stuck together, I can take it out of the fixture and just work with it on a flat piece of graphite and have a little better access to it and a little easier work environment. So I'm not trying to get it perfect in this step. I'm just trying to get it close enough that it sticks together. Also, something that I need to be very, very aware of, there are sensitive colors in my chips, and need to be very careful to not overheat and boil my color. And even as I'm narrating the video, talking about it, thinking about it, paying attention to it, sometimes I boil my color. So it's just an ongoing process of continuous improvement, continuous learning. But the good news about the process is that I'm starting out with fairly thick slices. These slices are a little bit over 1/4 of an inch. They're about 26, 0.26, 0.27, somewhere around there. And I have some, when I started I was using a lot thinner chips, and then I discovered that I really didn't have anywhere to go if I needed to do some cold work to kind of like grind off some of the scuzz on the surface. So now I'm using thicker chips, and of course that gives me a lot more wiggle room. When I finally grind the thing flat, I have a little more material to work with. My eventual goal, I like to have somewhere around 200 thousandths, 0.2 inches for a final result if everything goes well. But if everything doesn't go well, the piece will still have a nice looking surface, even if it's substantially thinner, like 150 or 125. But it's always a trade-off. That obviously I could use 1/2 inch thick pieces and have plenty of wiggle room for adjustment, but then I don't get as much yield out of my pull. And of course, the whole process, this whole multi-step process, is all interconnected. Every step affects the next step. So if I start with a 4-inch long core at a certain diameter, and that ends up resulting in a final pulled piece that's 7.5 or 8 inches long, that's how much material I have available to cut into chips and how many finished designs I can make out of one pull. Of course, if I started with a longer core, then I run into problems as well, because the squeezer dies are only 4 inches tall, and actually dealing with a 4-inch solid piece on the end of a punty is hard enough. And even if the squeezer dies were taller, just the dealing with the geometry of the piece, dealing with gravity, dealing with the way the weight of the glass and the way the glass behaves, it's really difficult to make a longer core than 4 inches. So I'm kind of constrained a little bit by the geometry that I'm working with. Of course, this is all assuming that I'm working with one single pattern that is cut up and assembled. If I assembled a chip stack out of pieces cut from multiple pulls, then everything changes. But at the moment, this particular design is all made from pieces from one pull. As I said before, the border on this has two purposes. First of all, I like the border. It's a nice decorative effect, and I think it adds to the design. But second of all, if I didn't have a border, I'd have to deal with the rounded over edges as I'm stacking and heating the chips. The edges tend to round over, which is not always a bad thing. Adjust the flame a little bit. There's good news and bad news about the Mirage hand torch. The good news is it's a great torch. I really, really love being able to go back and forth to get the big flame for heating a large area and then be able to focus the flame. Bad news is kind of heavy, and I've been wondering if there's some sort of a counterbalance or a sling or something that I could make. But then again, it's not that heavy. Only a minor annoyance. And yes, I could always just go back and forth between the Mirage and the smaller hand torch, but I really like just having it in my hand and having instant control. Okay. I realize that probably most glass workers, I know that when my teachers were teaching me to chip stack, they used what I assume is the more common technique, where you put your first chip on a punty and then using a bench torch assemble the stack in thin air. I just never had, I'll preheat my tongs a little bit. I just never had great success with that method. And, you know, being an inventor, I kind of thought, well, is there a tool I can come up with, a jig or something that I can come up with? So now I'm gonna move the assembly fixture. So anyway, I'm kind of getting distracted and kind of getting off topic here. I came up with the assembly fixture because in my other activity of machine work, fixturing is very, very common. And I use assembly fixtures, tooling plates, welding fixtures, all sorts of fixtures for everything I do. And so I had the idea, well, wouldn't a fixture make sense? And so far, it seems to make great sense. I'm kind of preheating. I'm switching to a flat graphite with a backstop on it. And I'm preheating. This is 1/2 inch thick graphite. I've tried many different substrates for this operation. I've tried steel, stainless steel, steel with kiln wash, very expensive piece of what McMaster Carr called high temperature ceramic that didn't work very well at all. And I think, do I actually have a camera problem here? Yep. Okay. Like I said, a lot of complexity going on here. Not only am I doing rather challenging glass work, but I'm trying to make a video, and I just wonder what's going on with the cameras and then while doing that, just having nothing but trouble today. This process is very picky about its timing, and while dicking around with the camera, I ended up getting the chip stack too cold. Oh, man. Okay. This process is fairly intolerant of timing mistakes. Okay, I believe that I have successfully recovered from that little sequence mistake. And now, hopefully, I won't have that same problem again. I don't know why the GoPro shuts off. There's a possibility that it may be overheating, even though I did fairly carefully put it in the airflow of my exhaust fan. Still, There's a lot of things to keep under control here. So now I have successfully transferred the piece. I'm using the flat paddle now. I'm thinking about making a special variant of a flat paddle that's more optimized for this particular operation, but at the moment just using a standard flat paddle. Of course, in everything I do, I'm constantly thinking not only as a glass worker, but also as a tool inventor. Hey, can I invent a tool to work on this, to make it better, make it easier? And of course that makes the adventure twice the fun. Using the backstop so I can apply a little bit of pressure with the end of the paddle. And kind of fill in those corners. Even though I resized the pole and then touched it up a little bit on the lap wheel, the corners aren't perfectly sharp. They're still a tiny bit rounded over, and so I need to kind of get them filled in while doing the chip stacking. I've been thinking about, well, what would it take to make the chips perfect? Or at least, you know, within machine shop tolerance, within a few thousandths, as accurate as I make my machine parts. And I got a bunch of ideas for lap wheel fixturing, and even trying to imagine, would it be possible to put a diamond tool in the CNC mill? Boy, wouldn't that be something. CNC milled chips. Probably come up with a whole lot of real precision geometry doing that method. But of course, ideas like that are so much easier just to think about. I have no doubt that when I actually try doing it, I'll discover all of the reasons that it's not easy. And I suspect there are many reasons that it's not easy. But, you know, the purpose of this exercise is not to be doing easy things. Glasswork is probably one of the hardest, if not the hardest thing I've ever attempted. Maybe that's why I love it so much. I'm trying to get the surface as flat as I can with the paddle to kind of preserve the thickness of my glass, because I don't want to be grinding away lots of material in order to get rid of the various different divots and low spots. So I'm trying to get it as precise as I can. My piece of graphite is pretty darn flat, and I'm getting better at just the skill of using the paddle and not creating divots as I'm doing it. I also have to be very careful about sliding the paddle. I kind of like sliding a little bit because it tends to even out, so I don't get like a real discontinuity at the edges. It tends to even out the surface that I'm sliding over. But on a previous one of these, I ended up smearing the pattern by being too aggressive with my sliding action. So, like everything about glasswork, it's all a balance. And that, I believe, is looking very good on the top surface. Yes, it is. So now it's time to flip it. Flip it good. Ba-na-na-na-na, bam, bam. Using the gas saver on the hand torch and finding it to be very, very useful. I really like it. Let me switch back to the first tool, because I've got some edges that need sticking together. Of course, the hotter the piece is, the easier it sticks. And of course, the bad news about this process is I continue to apply heat, and the graphite is sucking the heat out. The piece is just getting cold by its nature. And so, like everything else in this process, it's a balance that if I could get it hotter, the work would go faster, but it's also quite difficult just to work around very hot glass. Yeah, I don't want to... Got a little bit of boiling there. Here I am talking about managing heat, and while I'm talking about it, I'm getting it wrong. So, good thing I have a little bit of ability to correct in the cold working portion. This is probably, I don't know, the third or the fourth piece that I've made with the assembly fixture. Earlier pieces that I made, I did them on the plate, but didn't use the fixture, just kind of used the backstop and the paddle to push the chips into place. Of course, I can't say that I invented the technique of assembling chips on a plate, because I believe that's the way the soft glass guys do it, and I believe they call the assembly plate a pastorelli, and they probably have many, many terms in Italian to describe the different details of what they're doing, but this method just seems to work really well for me. I got a monitor, a video monitor on the other side of the shop. I'm just periodically looking over at it to see that the GoPro is still in action. I have no idea why it stopped recording. Like I said, glasswork is probably the hardest thing I've ever attempted, and so, hey, why not make it a little harder? Why not take the hardest thing I've ever attempted to do and then try to do a multi-camera video shoot with improvised narration. The backstop comes in very, very handy. It allows me to generate just a little bit of side pressure with the paddle. Of course, I'm not relying on getting the outside edge perfect because, as I said before, the outside edge is going to be rounded over, and I prefer a sharp, crisp corner. But I'll be getting that in cold work. I just finished making an attachment for the lap wheel with an indexing head. So when this guy gets to cold work, I'll be able to very precisely perfect the outer hexagon shape. But just in general, I like to get it as close as I possibly can in hot forming. And boy, oh boy. I do believe that I can call the bottom side complete and the top side very, very close to complete. Oh, looks like my little pilot light went out on the gas saver. Yeah, that top side is just about there. Almost no work left to do. And then a further benefit of this process, if my marine piece had any tiny little air bubbles in it, a lot of them can get closed up with the paddling. It's not perfect. I've still had maybe a little bubble here and there. Hard to get bubble-free marines. And I think I have this. I got a couple of little boily sparkles here and there, but overall, I believe this piece is coming out very, very nicely. And they continue to get, each one continues to get a little bit better. Just giving it a nice overall heat. Just make sure everything is fused together. Give the surface just the tiniest little chance to just kind of round over and flow together. And that completes the process. I believe that I am very happy with it. Of course, we'll see I make sure to preheat my tongs so I don't shock the piece. I won't know until it comes out of the kiln and I start cold working, but preliminary indication is, wow, this is a nice one. This may be one of the better ones ever. And I make my way through the obstacle course here over to the kiln. And that completes the job. Thank you for watching. It's been fun.